Welcome to Lesson 2, Circuit Playground Express, Topic 6, working with the accelerometer. The circuit playground has the ability to sense which way it's been tilted and motions in the X, Y, and Z axis. So let's get to it. So going to the website, we can see that the accelerometer has three functions, three primary functions. There are some other ones we can play with, but I'll leave that as an exploration for you. Motion X, motion Y, motion Z. We're going to play with the motion X and motion Y today. So let's get to our circuit playground. Close this out. So as you're already familiar, you have to do import the library, start the circuit playground. And we've been using the serial print line to kind of explore information. So we're going to do the same thing here. So anytime we interact with the circuit playground, we always have to write circuit playground. And today we're going to explore the motion in the x-axis. And like I said, we're also going to do the y-axis. But let's take one at a time. So I'm going to save it. Let's upload it. Okay, so let's open up the accelerometer. We should be getting some numbers popping up on the screen. So one of the things you're seeing, the numbers are definitely coming up a lot quicker. That's because we haven't put a delay in. But I think it's enough that the numbers are stable that we kind of figure out what they're doing. Let's bring up the camera. Okay, so always remember that the top of the camera is the where the USB cable is. So to move in the x-axis is to tilt either towards the left, or in your case the right, and tilt the other way. Now what I want you to do is look at the numbers on the accelerometer. Notice that tilting in this direction produces positive numbers all the way to 9. Okay? To tilt the other way, so here's the neutral position, kind of like in the middle. I'll see if I can try to get it. It's kind of hard. And then to tilt the other way are negatives. So the key thing to kind of realize when you're dealing with the motion direction is that to tilt in one direction is positive, to tilt in the other direction is negative. That's probably the more useful values to think of when dealing with the accelerometer. I mean, you could also kind of figure out halfway tilt is about a 4. So that's going to be key in a future concept when we have to deal with decision making. Right? What I'm going to do is I'm going to add the motion in the y direction as well. But I'm going to do it slightly different. I'm going to show you how to print several things on the same line. Now I wish there was an easier way of doing this. As in more modern languages, you're able to kind of concatenate information onto one stream to display it. Here you have to actually do several prints to actually get things to pop up on the same line. So we'll leave the last one as a print line. So if you recall, prints the information but doesn't skip down to the next line. The /t will cause a tab between the first piece of information and second. So there's a little bit of space between the two numbers, so we're actually able to distinguish between them. So I'm going to do a motion Y. And just to say, for the sake of making it a little easier to see the numbers, I'm going to delay it for 1/10 of a second. So let's save it. Let's run it. Once it comes up, we'll pull the accelerometer up. So you can see that we got two sets of numbers. The first one is the motion in the x-axis. The second one is the motion in the y-axis. So you might say, well, let me put up the camera. It's sitting on my table. It's not moving, but yet the numbers are moving. Again, these sensors are not high quality. When Adafruit produced this product, again, their envisionment was to make it something that was accessible to a lot of people. So they wanted to keep the cost level down. Now, I'm not saying these are bad sensors, but just realize there's going to be fluctuations in the values. So let's explore now. So let's go There we go. So if I tilt it towards one direction, notice how the first number changes. That's negative. I'm going to tilt it the other direction. And the other number kind of stays stable. It all depends on how steady I'm able to hold my hand. So that was motion in the x direction. Motion in the y direction, it's much like you would think on a piece of graph paper. It's tilting it this way. It's positive, and then tilting it the other way. It's negative. Now what you could also notice is I can actually do a weird tilt now. So I could tilt in two directions, both x and y. And as you could think, I mean, this now gives you a lot of flexibility. You can see I'm kind of moving it all around to be able to determine which way this thing is tilting. Now, I'm not going to display the z because it's a little hard on the camera, but the idea of the z is that it moves up and down. It produces, it gets more of an acceleration. So once it goes to stable, the z stays 0. And I'm going to leave that more of a project for you to explore, but realize that the z direction is up and down. So let's go back to our presentation. And today we reviewed the accelerometer. The accelerometer has 3 axes, x, y, and z. It's important for you to realize, depending on how you hold it, which direction is the positive, the negative in both the x, y, and z axis. Because then that's going to be crucial when you start making decisions with it. Thank you.